Yes, Assalamualaikum. Bismillahirrahmanirrahim. Today we will, after covering so much course, we will see that course description folder. What is that in our course description folder? We are going to cover that in this lecture. If you look at the course description folder, we have introduced the power electronics principles, converter components, and their effects, and control aspects. After that, we discussed power diodes in detail and reverse recovery characteristics, types of diodes, and RL, RC, LC, RLC circuits with diodes. After that, we have also discussed the trapped energy in the diode and freewheeling diodes. Then we move to the power transistors, which includes MOSFETs and JFETs and BJTs. We discussed them in very detail, including their origin of operation like saturation, cutoff, and active regions. And then we discuss their constructions, operations, losses, and their benefits. Then types of thyristors. Thyristor is a unidirectional device. We have discussed the four-layer model and then two transistor model for the thyristor. After that, we have also considered its transient response and thyristor turnover process. Then we discussed the snubber circuits, and along with there is one numerical discussing the snubber circuit. We didn't go into detail of the triggering devices. Just curtail or topic for thyristor until the snubber circuits. The control and protection of the thyristor is just the snubber circuits, the stray inductance, and the use of the capacitor with series resistor serves the purpose. Then we discuss the power converter, that is the rectifiers. In the case of rectifier, we discuss single phase uncontrolled. Diodes are used, then single phase semi controlled. In this case, this is very interesting. We are using a bridge, something like that. Then half of the circuit is constructed by the thyristor, and half is using the uncontrolled elements like diodes, and single phase fully controlled rectifier where we have to apply the thyristor where we can control the firing angles. And three phase uncontrolled, three phase semi controlled. Actually, semi controlled we didn't discuss in details. It's just you need to have idea what is this semi controlled. Then we discuss three phase fully controlled rectifiers. There come also some dual converters which can operate in four quadrants. Back to back two converters connected with opposite configuration. After that, we discuss the inverters, single phase inverters, and then we discuss the types, single phase current source inverters, voltage source inverters, and we discuss the details of the voltage source inverters with the single phase bridge circuit with inductive load, and then we also discuss some other parameters like three phase with 120-degree mode of conduction, three phase with 180-degree mode of conduction. Sorry for the noise. Actually, And the topic which we are missing is the AC to AC converter, and this is the whole topic we need to cover it up. And from the next topic, DC to DC converter, buck converter, boost converter, we already covered. Buck boost, we also did it. However, the last three isolated, forward and flyback, we didn't go through them. So we are left with AC to AC converter and these forward and flyback converters. Switch mode power supply and these control mechanism for the electric machines. We will do it if time permits. Let's come back to the first. We go for the AC to AC converters involved in this class. Okay, let's start. It's a chapter 11 from the book of Rashid. The arrangement of the chapter, it will list up the types of AC converters or controllers, their operations, characteristics, and it will also evaluate the performance parameter of each of the controllers. Okay, there are some parameters like alpha, beta. These are the AC or extinction angles. Frequency, Fs. Fs is the source frequency, F is output frequency. And you already know these terms. HF, FF, DF, PF, DUF, transformer utilization factor, power factor, displacement factor, fill factor, form factor, and the harmonic factor. I small I1, I2 is the instantaneous currents during mode 1 and mode 2. In line IABC, instantaneous currents of line ABC, IAB, these are the phasor currents between line AB, AC. And when we are considering capital, then this is the RMS currents and RMS currents between phase currents between the lines, and IR and IRMS and average thyristor currents. And small letter only denotes the instantaneous. K is the duty cycle. VS, IS the instantaneous input supply and current respectively. VO, V0 is also output instantaneous voltage and the current. Let's start with the DC and DC voltages. Output voltages are denoted like that, and the gate signals are denoted by small letters G1 and G2 for your switching devices. RMS voltages for the input and the output, volt ampere rating and output power. Introduction, since it's a AC to AC converters, let's read through. It's pretty important, you can understand very easily. If a thyristor switch is connected between AC supply and the load, the power flow can be controlled by varying the RMS value of the IC applied to the load. Note that we have an end-to-end device. We are feeding the AC and certain device. We just place a thyristor in between. We can vary the RMS value supplied to the load, and this type of power circuit is known as the AC voltage controller. Now we have a very simple example over here. Let's give me a second. Welcome back. Sorry for interruption. We have a very common example in this case. Uh, if you have turned on your fan and you want to control the speed of your fan, you have a very smart dimmer connected in between three sides, and you are feeding the AC supply to the load. The load is your fan, and you are just trimming the AC supply with the help of this voltage dimmer. That is the best example for the AC controller or AC to AC converter. Here, most common application of AC voltage controller are industrial heating, on-load transformer connection changing, light controls, speed control of polyphase induction motors, and AC magnetic controls. These are the very sophisticated types. For power transfer, two types of controls are normally used. On-off control, that is, you just use a switch to normalize the speed. Other is the phase angle control. It's a very interesting things. In on-off control, thyristor switches connect to the load. Connect the load to the AC supply for a few cycles of the input and then disconnect it for another. Yes, it's just on and off, and to control the RMS value delivered to the load. So on for a certain period of time and off for a certain period. It's also pretty interesting. You can control things with that in this way, just on and off. The second thing is that, which is in phase control, thyristor switch connect to the load to the AC source for a portion of each cycle of time to voltage. Actually, this is your dimmer. Dimmer, what does it do? It just clips some of the portion of the wave and fed the rest of the portion to the fan. And fan makes certain noise because the shape produced by the dimmer has a lot of harmonics. The AC voltage controllers are classified into two types: single phase controllers and three phase controllers. And with each type subdivided into unidirectional or half wave control and bidirectional or full wave control. Yes, it's a similar to the rectifiers, half wave, full wave. Various configuration of three-phase controller depending on the connection of the thyristors, which is like delta and star. You know the star. We'll discuss this in detail in the lectures, suppose in the case of rectifiers. On-off control is used only in limited application. Half-wave semi-converters have some advantages. For example, better input power factor and less switching devices. The full wave converter have a wide range of output, voltage control and better power factor than the half-wave controllers. Yes. Input power factor is better for the half-wave with less switching devices. However, for the full wave, your control is better. Half-wave controllers are not discussed anymore. Actually, in third edition, Dr. Rashid has discussed half-wave controllers, but in the fourth edition, he just omitted that topic from everywhere, from rectifiers, from fully controlled rectifiers, AC connectors. He removed that half-wave part. He just start from the full. Let's start with the same. There are types which will be covered in single phase full wave, three phase full wave, and rest we will see if time permits we go for the three phase bidirectional delta and transmission. Most probably we will stick to the three phase controller. And look at this. Thyristor can be turned on and off within a few microseconds, maybe acting as a fast devices to replace mechanical and electrochemical circuit breakers. For low power DC application, power transfer can also be used, and static switches may have advantage very high switching speed, no moving parts, no front head, bones and closing. Actually, thyristors are the devices which can be turned on in microsecond scale, on and off, which are better than the mechanical switches. Since the input is the AC voltage, thyristors are line converted and phase control thyristors because which are less expensive and relatively have a larger speed as compared to 400 Hz trials are available to meet the voltage and current. They are more commonly used. For this frequency range trials. Due to line and natural combination, there is no need of extra communication and the circuit for AC controllers are very simple. Actually, we already discussed this line in post communication. In the case of thyristor, actually turn on the thyristor is not a big deal. We just apply a pulse and it is turned on. However, controlling the turn off properties is difficult, very difficult for the thyristor. There are two methods which serve the purpose, that is the natural commutation, which means when your waveform is crossing from positive side to the other side, like the sinusoid case, then the thyristor in the unidirectional device it is automatically forced into the turn on, and you don't need an extra circuitry for that. However, if you place a force combination, fully you need an inductor and capacitor and another thyristor. Okay, and let's keep moving. Performance parameter of AC controllers. As far as it is concerned, we already discussed the performance parameter of rectifiers in detail. We will see here. Okay. Now, look at the diagram first. Let's we'll come back to our original topic. This is just an introduction. We have a AC to AC converter. We fed a voltage and we have output voltage. Look at this. This is our input supply. This is our output. You can see that output is sequenced somewhat. Every waveform will start from 0 to pi. In the case of it is delayed by a certain angle alpha and stripped off at certain point. And similarly is the case with the negative half cycle. However, in the case of currents, source currents, well, let's see, currents is little bit delayed. The reason is that when you are using these devices for a very highly inductive load, what will happen? The current, the inductor has an inherent property, it doesn't allow the current to change across it abruptly. That's the consequence which we are seeing over here. It is also affecting the source current. It is reflected back into the circuit. So this is an particular example for that. We can see that very clear. This is one of the example. We have our input and we have this kind of output and the source current, and you can see that it is somewhat delayed. Okay, let's come back to the origin topic. Okay, there are some performance parameters which are discussed similar to the inverters and the rectifiers. Output power, RMS output current, output frequency, total harmonic distortion of the output, thrust factor. We already discussed these in the rectifier in very detail. Harmonic factor, form factor, and ripple factor. Actually, these determines the efficiency or the how useful is this converter is. Okay, let's start. Single phase full wave controller or converter. Actually, mentioning is the load type is very important because depending on the load, the behavior of the converter is different. A single phase full wave controller with a resistive load, you can see in 11.2. Okay, let's go to the, oh, which is interesting. It's a single phase full wave controller. It has two thyristors back to back, T1 and T2. Since thyristor is a unidirectional device, it can conduct only in one direction. It can conduct in one direction, and you cannot force it in two direction or something like that, like that some other devices. And this we have talked about is the resistive load. Okay, that's correct. During the positive half cycle of the input voltage, power flow is controlled by varying the delay angle of thyristor T1. Okay, let's go. During the positive half cycle, we have a cycle. This is the T1 is responsible for the conduction of the positive half cycle, and we can control the flow. Whenever you want it to fire, you just apply a control signal to the gauge of the thyristor and it starts conducting. Similarly to that, thyristor T2 control the power flow in the negative half cycle. That's great. And the firing pulses of T1 and T2 are kept 180 degree apart. Yeah, this is really interesting. Firing angle is alpha, and these two pulses, if you are firing something over here, then this is the firing pulse for the thyristor T1, and this is the firing pulse for the thyristor T2, and their phase differences. I think that's enough for this lecture, and we'll come back for another lecture after a while. Thank you very much.